day of new material. The last day of the semester is Wednesday. Today we're going to cover equations involving fractions. Wednesday is just going to be a review period, but it's going to be like our other review periods in that I'm just going to give like a 5-minute brief overview of what's on the test, and then the other 65 minutes you guys are just going to work on whatever you want to work on. There are lots of practice problems to try. There's old tests, old homework, lots of things to work through. All right. I can give copies of the old quests. The quests are not on Moodle. Yes. Yeah. Yeah. If you want blank copies of the quests, I'm happy to make them. Are there other folks who are interested in? All right. Show of hands if you want a blank copy of all the quests and tests. I'm going to print them. So we'll take care of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and Katrina, I'm assuming Katrina's out. All right, she had the suggestion. And okay, so I will make copies of all the quests and tests and bring them on Wednesday. Good suggestion. All right, the test again is coming up on Monday. Officially, our window starts at 1 o'clock. We're going to have an extra half hour if we want it, so show up a little bit early if you're able to. 12:30 until 3 on Monday coming up. So 1 week from today, this class will be completely done. There is still the final exam to take and some old homework that some people can make up. There's still room for people's grades to change significantly in this last week of the semester. It can go way up if you turn in old homeworks that you're missing and do well on the final. It can go way down if you do poorly on the final. The final's worth, I think, 15%. I mean, it's not 40%, but it's also not nothing. So there's still lots of points out there to be had or missed. So I know that we're tired and some people are sick, but if you can find those hidden reserves of energy to just get you to that finish line, within 1 week, we will be completely finished. So whatever you can give to this course in that time, again, there's lots of opportunity, grades to go up and down. Okay, so we're starting here on page 85. And today we're going to solve equations that have fractions in them. This is different from what we've been doing the last few classes, because the last few classes we've just been combining fractions. Instead of having an equal sign, we would have a plus sign. And we worked on how to add these two fractions together. Now we are solving. We're going to find x that makes this equation true. Okay, so the technique, you can see the circles here are the same as before. The technique is a little bit different, but the starting part is the same. We still need to find the LCD. So what do we do to these denominators? As we factor. Can we do anything with x? No, that's just x. Can we factor anything out of 6x plus 3? We'll factor out of 3. And then what do we have left? So 2x plus 1. Is that all right? Okay. Step 2, we're looking for the thing that they have in common. So do they have anything in common? The answer is no. It looks like maybe there's an x that's in common, but this x is not exposed. It's part of 2x plus 1, which really has nothing to do with that single x sitting over there. So what do we put in the left-hand oval? We put x, and in the right-hand one, 3, 2x plus 1, and in the overlap, nothing. Okay, so putting that all together, the LCD, we just read straight across. X times 3 times 2x plus 1. This is old, nothing new so far. Now we get to the new thing, and the new thing is this. It says here in step 3, step 4, copy your original equation, leaving a big space next to each fraction, or next to each term. A big space next to each term. So I'm going to copy the original equation down here, 1 over x. I'm going to leave a big space, then I'm going to put the equals. And then on the right-hand side, I'm going to copy 8 over, but I'm not going to do 6x plus 3. We want to put it in factored form. 3 and 2x plus 1. And then a big space next to that one. Any questions at that stage? Copy the equation, big space next to each term. Okay, here's what we're doing in step 5. Multiply each and every term on both sides of the equation by the LCD. Each and every term gets multiplied by the LCD. So in this blank space, I'm going to put that LCD. I'm going to put it right here in parentheses. X times 3 times 2x plus 1. That's what the big space is for. And then the same thing on the other side. X times 3 times 2x plus 1. No, we're not looking for what's missing, and that is very different from what we were doing before. Okay, and let's be clear about why it's okay to do what we just did. What we did is multiply both sides by the same thing. We're allowed to multiply any equation by the same thing on both sides, right? So I could have multiplied both sides by 5 if I wanted to, but that's not as useful as what we just did. We multiply both sides by the lowest common denominator. It's okay because you're doing the same thing to both sides. And that big space is supposed to just be the LCD, and it represents multiplying. Now, just to make it so that we're really clear where these things are, I'm going to force this to be a fraction. So I'm going to put over what number? Over 1 and over 1, which is also very different from what we did before when we had the missing pieces. We put foo-foos in, right? We put the same thing on top and bottom. Is this a foo-foo? No, it's not a foo-foo, but that's not the point. The point is multiplied both sides by the same thing. Okay, here's the good news. The good news is you can cancel. Don't multiply, actually cancel. Anything you see that's the same on top and bottom goes away. So for example, this x right here cancels this x right here. Yeah, on the right-hand side, what goes away? 3 cancels. What else? The 2x plus 1 cancels. Everything cancels. Yeah, a lot of people find this easier than the other thing. So let's write down what we have left. Upstairs, it used to just be a 1. I'm going to copy that, although it won't matter. What else remains from the green? 3 and 2x plus 1 equals, yeah, what used to be upstairs was the 8. What's still there from the green? X. It was just a placeholder. I mean, you can cancel the ones, and you definitely don't need to put it here, but it's just a placeholder, just so that we really see that thing is on top, and so it's okay to cancel. You don't need to write the ones. What is much better about this equation compared to the first equation? Yeah, and what have we gotten rid of? Fractions, right? We had fractions, now we have an equation with no fractions. Okay, so let's solve this like a normal old equation. So how about we distribute that 3? I won't bother writing the 1. So 6x plus 3 equals 8x. And it looks like a few steps from there to get to the answer. So go ahead and solve for x real quick. X equals 2/3. Is that okay? Sorry, 3/2. Yeah, 1 and 1/2 is the default for a lot of folks, but mixed numbers like 1 and 1/2 are not as easy to work with as improper fractions. 1.5 is okay. Okay, so that is the answer. Now here's step 8. Last step with just about every algebra problem is check your work. But oftentimes we don't even bother mentioning it. We just assume we did everything right, and therefore we got the answer right. Bad news. For the, I think, first time all semester, you can do everything right, and you can get an answer that doesn't work. which is really disheartening. We can do everything right, and yet x equals 3/2 is not a solution to the equation. It's quite possible when you have equations that have fractions in it to do everything right, and still the answer at the end doesn't work. So it is absolutely mandatory for us to check our answer whenever we have equations involving fractions. So what does it mean to check the answer? Well, unfortunately, it means a lot of work. What was the original equation? Thank you, Drew. What we should do is change those x's to what number? 1.5 is okay. I'm going to leave it as a fraction. 1/3. All right, so let's check right here. So this goes 1 over what? 3/2 equals, I'm going to put a question mark because I don't know if it's going to equal 8 divided by 6 times 3/2 plus 3. Sometimes checking your answer is almost as much work as actually getting the answer. 1 divided by 3/2. What does 1 divided by a fraction do? It flips the fraction. That 3/2 is going to become 2/3. Yeah, and actually that's the keep, change, flip thing we talked about. So this is just going to be 2/3 equals maybe. All right, 6 times 3/2. It's 9. So this is really 8 divided by 9 plus 3. That's 8 over 12. Sebastian, how'd you get 9? 6 times 1.5. So 6 times 3 over 2. Cancel those guys and make a 3 up there and a 1 down there. So that's 9. Okay, is 8/12 the same as 2/3? Yes, so it worked, but it doesn't always work. And so you do need to check. But I'll give you a shortcut. The shortcut is, and I say this hoping that it's true, I assume it's true. It's never not been true for anything I've ever seen, but I haven't seen a proof that this thing is true, so I'm hoping that what I'm saying is true. Maybe I should pause the video just in case what I'm saying isn't true. But we'll just say it. When you check, the only thing that you need to watch out for is dividing by what bad number? 0. 0 is a very bad thing to divide by, right? So suppose that up here, instead of getting x equals 3/2, we had gotten x equals 0, which is normally a perfectly good answer. What's the problem when you try putting x equals 0 in? You divide by 0. You see that? So as soon as I get x equals 0 and I look at that, I say, nope, x equals 0 is not a solution, and that's okay. Another possibility. Suppose that we had gotten, where are we here? Suppose that we had gotten x equals -1/2. Plug -1/2 right there. Good question. So we'll talk about what we need to write if it doesn't work. But what do we get here? We get 0 in the bottom. If you plug in -1/2 for x, this guy down here is 0. Right away, I don't need to check. I don't need to do more work. I just need to make sure I'm not dividing by 0. If the answer is, yeah, you get 0 and it doesn't work, then right down here, we would just say something like x equals 3/2 isn't a solution. If it didn't work, isn't a solution. And that was the only potential solution. So the answer to this problem is no solutions. You could also say something like, reject. You know how you'd reject the negative? You can reject 3/2. So if it just doesn't work, you reject it. So I'm going to put this here in a box. This is kind of in imaginary land because x equals 3/2 is a solution to this problem, but it could very well not be. Evan.
Did I miss something?
Yeah, we flip the fraction.
Okay. Right.
Okay. All right, let's try another one of these. We're going to do a few more together. Okay, we're going to skip the next page for the time being. Let's go down to this one with the 2 copies of the box right next to each other. Everybody see it? What page is this? 87. Okay, page 87. So one thing I'm not thrilled about is that there are how many terms here? There are 3. But the good news is the first one just has a denominator of 1. I can ignore it. I don't need to worry about that. But let's look at the other ones. Factor this one. Can we do anything? Factor this one. And we'll take an x out to the front. And what do they have in common? X minus 2, that'll go in the middle. What do we need to put in the far left? You could put a 1. If you're going to put anything, it's got to be a 1. You don't need to put anything because there's nothing left over there, but if you want to put something, it's a 1. In the right-hand part, what's missing? Just a single x. Okay, so reading the LCD straight across. 1 optional, x minus 2, and x. So there is something that isn't optional that I didn't put in. Where do we need parentheses? Around the x minus 2. That's one thing, right? It was in parentheses before. I probably should have kept it in parentheses there. Definitely need it in parentheses there. So that's our LCD. Next thing to do is copy that original fraction. We're going to put these denominators in the new factored form. But what else are we going to do when I copy the equation? Before we multiply, we're going to leave that big space, knowing that we're going to multiply. Right, so we're copying this equation, big space, next to each of the 3 terms, each of the 3 fractions. So there we go. So we've got over here a 2 and then a big space. What's the next fraction? 1 over 4 over. Plus 4 over x minus 2 and then a big space equals. And the last one is an 8 over. But we really want to put this in factored form. Good. Right, so we'll copy the thing, big space next to each fraction, each term. And then what goes in that big space is the LCD. It even says it there. It says fill in the spaces with the LCD. So next to each of these fractions, I'm not going to put the 1 anymore. I'm just going to put x minus 2 times x. There we go. That goes in the one fraction, goes in the next fraction, x minus 2 times x. And then the last fraction, x minus 2 times x. Again, you're welcome to put over 1 if you want to, if you really want to make them look like fractions. You don't need to. The thing that we just did that makes this legal, it's a really strange thing that I'm saying to do. Put something in the blank space next to every fraction. What we're really doing is multiplying both sides by x minus 2 times x. That's all we're doing. But if we multiply, this whole thing by something in the front, so let's say we just multiply by 5 to make it easier. What would we do with that 5? Because there's a plus sign in the parentheses. Wouldn't it come in and hit the 2 and also hit the 4 over x minus 2? We know it would distribute. So that's what we're doing. We're just not writing it out. We're taking something out here and we're distributing it next to each part. And that's what's going on in the blank space. 2 times this thing, and then the fraction times that same thing. Just everybody times the LCD. Okay, and now if we've done good things, then all the fractions should cancel. What cancels in the second part here in the middle? So the x minus 2 cancels completely with that guy. Still have the x up there. On the right-hand side, what cancels? The whole thing cancels. X minus 2 and x minus 2, x and x. And if you're doing a problem like this and the whole denominator doesn't cancel, you've done something wrong. It's the point of putting the LCD next to all the fractions, is that it will cancel with every single denominator. Okay, so now we write down what's left. So I'm just going to copy whatever's left. 2x minus 2x plus. So we have the 4 in blue, and then the purple x is still left over, 4x. What's the only thing on the right-hand side? 8. And again, what have we gotten rid of? All the fractions. All those denominators go away. If it's all the same to you guys, I'd like to move on to the next problem, because there's nothing new left to do in this problem. That's a problem that I gave you guys on the first day of the semester, something like that. Solving a linear equation is something you guys have been able to do for a long time. So I'd like to just move on so we can keep practicing the new thing. And I'm just going to put ... I mean, solve it in the normal way, but there's nothing new to be gained from the rest of this problem. Everybody okay? We'll move on. Let's take a look at this next one at the top right. 2 over x plus 1 plus 4 over x minus 4 equals 1. Okay, factoring the first one. X plus 1, nothing to do there. Factoring the second one. X minus 4, nothing to do there. The third one it's not even a fraction, so I'm not worried about it. What goes in the overlap? Nothing. Even though it looks like x plus and x minus, can't do anything there. Those x's are not the same. So on the left-hand side, x plus 1. On the right-hand side, x minus 4. Nothing in the middle. So the LCD, x plus 1, x minus 4. What goes in between? Yeah, definitely need parentheses here. I'll put a dot just to really highlight the LCD is the product all the way across. Okay, so now we take the original equation, but what do we insert? Spaces, lots of big spaces, and we know what we're going to put in there. So we're just going to copy. Okay, so it was 2 over x plus 1. What was the next part? Oh, I need my spaces. 4 over x minus 4. Space equals, and on the right-hand side was just 1, right? Okay. And what goes in these spaces? LCD. So x plus 1, x minus 4, 3 times. Okay, so let me save you guys, some of you guys, some points on the final exam. It's really tempting to maybe multiply these things through. I could do FOIL right here, yeah? And then I can multiply everything by 2. Perfectly legal. I'll just put the answer here, so I get 2x squared, let's see, minus 6x, and then minus 8. That would be divided by x plus 1. So I could do that. Yeah, I mean, the fact of the matter is, this 2x squared minus 6x minus 8 factors. In fact, you've got it factored up there in blue and purple, and something cancels with the x plus 1. It's not at all clear that something cancels with the x plus 1 now because it's all distributed out. And so not only does it take time to do this, but it's really not helpful at all. Like, you'll get to this funny equation with way more complicated things than what we had at the start. The goal is to make the equation simpler. So avoid the temptation to distribute. You don't need to FOIL just because you have something you can FOIL. So what we do need to do is cancel. So what cancels in this first part? X plus 1, it just goes away. Don't distribute. You cancel first. That's why you put it there. What cancels in the middle part? X minus 4 cancels. And right away, things get a lot easier upstairs. What cancels in the right-hand part? Nothing. There was no denominator there. It just sits there. Okay, so let's write out the new equation. There's still a 2 there. What else is there? X minus 4 in parentheses. Plus 4 x plus 1 equals. Yeah, no reason to copy that 1 anymore. Okay, now what you are obligated to do is distribute. You have to distribute now. But what have we gotten rid of? The fractions. The whole point of today is that you can take equations with fractions, do this thing with the space and throw in the LCD in there and canceling, and get new equations. I'm not saying the new equations are easy, but they don't have fractions anymore. And we spent a lot of time this semester learning how to solve equations like this guy without fractions. So you do need to distribute. I'm going to put dot, dot, dot here, but I will say there's a lot of work in this dot, 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 because when you FOIL on the right-hand side, what's the first thing you're going to get? Is x squared, right? So this guy is a quadratic, and you're going to either use the quadratic formula or maybe the whole thing factors. Do we want to see more details on this one? There's work to do on this one. So we're not going to finish, but we'll at least get you a little bit closer. So we'll distribute the 2 and the 4. 2x minus 8 plus 4x plus 4. And then we'll FOIL over here on the left, or sorry, on the right. Left-hand side, let's combine some terms. How many x's do we have? 6x. What about the constants? Minus 4, and then I'll just copy the right-hand side. And every step is supposed to look a little better than the previous step. So if things start to look worse, you probably took a misstep somewhere along the way. It's got an x squared. What do I want on one side? Almost every x squared equation we have, there's one particular number we want on one side. It's 0. We're desperate to have a 0 over there. So subtract the 6x, add the 4. Did I make a mistake, or are we okay? Subtract the 6x, that makes the minus 9x. That minus 4, when you add to both sides, cancels with the other minus 4. Michelle, what's happening? Oh, then we have to solve. It's close to that, but it's not exactly that. This one does factor, but there's something that goes into both of these terms. It's a single x, so it's this kind of factoring. What's left in the parentheses? X minus 9 is good. Yeah. So then, yeah, we're good to go. We just split it right down the middle here and set each of the two pieces equal to 0. So either x equals 0, that's the first part, or x minus 9 equals 0, that's the second part. And it's okay to do that because you made it multiplication. Yeah, we do have to, so let's take questions, but then we do definitely have to think about checking. Questions on getting to 0 and 9? So even after you get rid of all the fractions, which is this top line on the screen, there's oftentimes still a lot of work to do. So again, all we're doing is translating one fraction equation for a different equation that has no fractions, but it could still be a lot of work. And again, we are obligated to check, but let's do the real short version of the check. X equals 0. Remember I said you can't divide by what number?
0.
Can't divide by 0. So is this a problem for us? Do we just reject 0 every time we see it? Go all the way back to the beginning equation. If you plug x equals 0 here, what do you get? You get 1, which is totally okay. If you plug x equals 0 here, what do you get? -4. Lovely. That's going to work. If it becomes a 0 in the bottom, you reject it. What was the other answer for us? 9. If you plug 9 for x, what do you get? 10. Great. Plug 9 for x. 5. Super. That's going to work as well. But if we had instead gotten x equals 4 as an answer, then there's a real problem. Because right there, you'd be dividing by 0. This guy, if it came out, would get rejected. So what if your answers had been this? X equals 4 and x equals 9. Does 4 work? No, can't divide by 0. Does 9 work?
Yes.
Yes. So then in this case, you'd say this is the only answer. So you'd have two answers that come out, but maybe one of them gets tossed and the other one is legitimate. Sebastian.
What if, I mean, I did it the way you did it, but I also did it I got 9x equals x second.
Yeah.
Worked out from that.
Yeah, same thing. Yeah, that's good. Okay, so we're doing one more together and then it's group work. I saved the best for last. Here we go. This one that we skipped right here, I would like to change. I'll say you can try this later on. This is one where you're going to get an answer that doesn't work. Can you look at this and know what answer is very bad for x? X equals 3 is very bad. You're going to do all this wonderful algebra, and if you do everything correctly, the final thing should say x equals 3, and then you say, nope, doesn't work. Right? So that is an example where even though you do everything right, still doesn't work. But we're going to do something different than this. We're going to do a tougher one. Let's try this one here. 2 over x plus 5 plus 7 over x plus 2 equals -3 halves. So copy that one down. It's not in your packet. Okay, so what makes this one worse than all the ones we've done? Yeah, there's 3 fractions in this one, right? All the other ones we had only 2 fractions. So, yeah, one of them was just a 1. It was no problem. So I guess technically there should be like a third circle in here, and really it's just the stuff that's in all 3 that it gets complicated with the third circle. So let's just talk a little bit about it. Can you factor any of these denominators? No. So then the left-hand part, left-hand circle gets the first one, x plus 5. The right-hand part is an x plus 2, and then the top part can be the other fraction, just plain 2. Those are our 3 denominators, and they have nothing in common, so I put no space in the middle. Thoughts on how we can get the LCD? And multiply them all together. Just like we did before, we'd always multiply what was in the circles. It used to just be a straight line, but we can wander around here. X plus 5, x plus 2, 2. That's the LCD. Okay, so this step seems kind of silly, but I think it's worth doing. We're going to copy the equation, but before the LCD, we'll just leave a little space for it, right? So I'm copying 2 over x plus 5, with a space, 7 over x plus 2 with a space, -3/2 with a space. What goes in all the spaces? LCD. So squeeze that into each space. What cancels in this first fraction? X plus 5 will cancel with this x plus 5. Now let's pause right here and let me just highlight that it is a very, very, very bad idea to multiply that through. The LCD in factored form is useful because then you can see right away, oh, x plus 5, we can cancel them. But if you decided you were going to FOIL this LCD together because you think you have to FOIL every time it looks like FOIL, then you won't recognize that something cancels. So leave it factored. What cancels in the middle fraction? X plus 2 cancels here. In the last fraction, 2. So just cross off the 2, cross off the 2. And then I'm going to copy this thing down here, just writing down what's left after all that canceling. So what was the denominator? Sorry, what was the numerator in the first fraction? It was a 2. It's still a 2. And what's there from the purple? X plus 2 and another 2. Plus. The old denominator, sorry, the old numerator is still there. What is it? 7. And now what's left from the purple? X plus 5 and 2 equals, just copy that equal sign. The old numerator is still there. And then from the purple, good. Any questions on getting to there? I feel like this is one of these where it seems pretty straightforward when you're watching somebody that knows how to do it, when you're watching them do it, but it's something entirely different to make sure that you can do it from just a problem and a blank piece of paper, and that's the skill that we need you guys to get before Monday. That said, I'd like to stop this problem here and give you guys a chance to really practice with a problem and a blank piece of paper. There's still a bunch of work to do in this one. You have to distribute all those things through, right? We can't have all those parentheses there. So you distribute, including foiling on the right-hand side. When you FOIL on the right-hand side, you're going to get an x squared, yes? That means it's a quadratic equation. You're going to end up with a whole quadratic equation, just like we did on the previous problem, which should either, you get it to 0 and it either factors if things are good, or a quadratic formula if things aren't so good. Any questions? What's that? What is the answer? Say it again. I think that sounds right. Positive or negative? Both negative. These are Katrina's 2 answers. -4 sounds familiar to me, and I actually built it so -4 would be an answer, and then the other one I didn't pay attention to. So Katrina says those 2. I think that seems pretty good. So as you check later on, you can verify that those are your answers. Okay, so we have 27 minutes, 28 minutes. We're going a couple pages down the road until we find this group activity on page 89. So go to page 89. There are a bunch of problems there. You might need to draw your own ovals if you like the oval method. I'll put the flags out. You guys will work with each other. I'll help if I can. And let's see how far we can get. Okay. All right, so A and C, we had some issues with the hole punch. Can we see that? Those are both 2 X's on the first one. Okay, so let's see how far we can get.